This video covers several factoring methods, GCFs, binomials, trinomials, as well as the grouping method. It also covers solving by factoring. There are several solved examples. I encourage you to pause the video throughout and try the problems on your own. Now let's get to the questions. The next question is asking us to find the GCF of these three terms. It doesn't say to factor it, just write down what the GCF is. So when we're looking at GCFs of variables, we always go with the lowest power of the variable, and the variable has to be in every term for it to be in the greatest common factor of all three terms. So we have a 12, an 8, and a 9. So we go with the lowest, so x to the 8th. And then we have a y to the 4th, y to the 5th, and y to the 6th. So the lowest y to the 4th. So this is the complete GCF, x to the 8th times y to the 4th. This next problem is asking us to factor out the GCF. We can see that in our coefficients 14, 12, and 6 that they're all even numbers, so we have a factor of 2. So our GCF, we can at least pull out a 2, and for the x's we always go for the lowest power, so x or x to the first. So that's what we will be factoring out in front, and we've got to figure out what goes here. It'll be three terms. So 2x times what will give us 14x cubed. 2 times 7 is 14, and x times x squared is x cubed. For the next term, 2 times what will be 12, and that's 6, and x times another x would give us x squared. For the last term, 2 times 3 would give us 6, and we already have the x. So this is considered the fully factored answer. This next problem wants us to factor this trinomial, so we want to see if we can factor it into two binomials. Since the first term is x squared, we know that these two will be x times x, and for the two numbers that go inside these binomials, we're looking for two numbers that multiply to equal 10 that will also add up to negative 7. What multiplies to be 10? We've got 1 times 10, and 2 times 5. But to add up to a negative, we're going to need negatives on these, and we could see that this is the pair negative 2 plus negative 5 that would add up to negative 7. You can always check these problems by FOILing them or multiplying them through. So if we distributed like the x squared, x times, so this is the check, x times negative 5 is negative 5x, and negative 2 times x is negative 2x, negative 2 times negative 5 is positive 10, and these add up to negative 7x. So we can see that we get back to the original problem, which tells us our factoring is correct as long as there's no GCF remaining inside these two parentheses, and there's not. Number 28 is asking us to factor this trinomial. There's no GCF involved because the first two terms have an x in them and the last two have y's in them, but none of them have an x and a y. And as far as the coefficients, the lowest one is a 1, which we don't factor out a 1. So we are going to check to see if this factors into two binomials. Again, this is x squared, so it'll be x times x. This last term has a y squared on it, so we know these two have to have y's. So now we just need the numbers in front of the y's. So we're looking for two numbers that multiply to be negative 13 that will add up to negative 12. So since 13 is prime, the only way to get negative 13 is either 13 times negative 1 or negative 13 times 1. The pair that adds up to negative 12 is negative 13 and 1. So one of these is minus 13 and the other one is plus 1, but we don't need the 1 in front of the y. Again, you can check these by multiplying it through to to see if you have the correct answer. So x times x is x squared, x times y is xy, and negative 13y times x is negative 13xy, and negative 13y times y is negative 13y squared. These two middle terms will add up to negative 12xy, which will get us back to the original problem, so we know our factored answer here is correct. For problem 29, they are giving us one of the two factors and asking us to factor the problem. Basically, they just want us to fill in this binomial. So these are a little bit easier to do than if they hadn't given us the 10x minus 3, because we could just check these two things. 10x times what would give us 50x squared, and 10 times 5 and x times x would give us the 50x squared when we multiply those two. For the last two terms, negative 3 times positive 1 would give us negative 3. Again, we can check to make sure that this works. 10 times 5 is 50, x times x, x squared. 10x times 1 is 10x. Negative 3 times 5 is negative 15x, and negative 3 times 1 is negative 3, which I'll just write as minus 3. So 50x squared minus 5x minus 3 does check. Number 30 is asking us to factor this trinomial. It's the harder kind of trinomial where a does not equal 1, because a is 2 here. So because of that, we know that one of the factors has a 2x and the other one has an x in order to multiply to be 2x squared. We learned a few different methods for factoring these harder type trinomials. We could use grouping, or we could use guess and check. We could also use slide and divide. For this problem, since 2 is prime and 13 is prime, there's only going to be 4 options if we use guess and check. So I'm going to go ahead and use guess and check. So by guess and check, you just fill it in and see what works, right? So here's 3 of the 4 options, and here would be the 4th. And let's fill them all in. And what do I mean by that? Well, these two numbers have to multiply to be negative 13, but they're each multiplying off different things, either the x or the 2x. We can either have negative 1 times positive 13 like that, or if we reverse the order, we could have positive 13 and negative 1 like that. They're multiplying off of different terms here, so those would be 2 different answers. We could also change the sign of both terms, so positive 1 and negative 13 like that, or positive 1 with the x and negative 13 with the 2x. I'm just going to check. So here I've guessed, I've written 4 guesses out, and now I'm going to check that the inner and outer, I'm going to multiply them and add them together and see if they add up to this middle term of negative 25x. So here we have negative 1x, and on the outside we have positive 26x. Clearly those add up to positive 25, not negative 25. But it also gives us a clue as to which one will work. Since we got 25x and we want negative 25x, we just need to change the signs of those numbers. So that means this one should be the one that works. 1x and negative 26x adds up to negative 25x. So this is the combination that works. If you tried these others, they will not work. You have negative 13x and positive 2x, which adds up to negative 11. And on this one, you'd have 13 minus 2, which would add up to 11x. So the correct factorization is the binomial 2x plus 1 times the binomial x minus 13. Here is another factoring problem in which a does not equal 1. It equals 3. So we don't have any GCF here to pull out, so we're stuck with either using guess and check, slide and divide, or grouping. I'm going to go ahead and do this one by slide and divide. So by slide and divide, you take the 3 off of the first term and multiply it by the last term. But don't worry too much about that. We will end up dividing that out at the end. We next ask ourselves, what are two numbers that multiply to be 63 that will add up to 17? And your factors of 63 are 1 times 63, 3 times 21, or 7 times 9. None of these, if you were to add them, add up to 17. So that's what tells you this polynomial is a prime polynomial, which means it cannot be factored. This next problem is asking for us to factor it by grouping. Grouping is always the method we want to use when we have 4 terms, although we could have added these two together to create a trinomial and factor it that way, but they're specifically asking us to use the grouping method. When we factor by grouping, we're trying to pull the GCF out of these two terms and then the GCF out of these two terms as a first step. The GCF of the first two terms is simply x, and x times 4x would give us 4x squared. X times negative 3 would give us negative 3x. Whenever there's a minus here on these two terms, we need to factor out a minus, and the GCF of 12x and 9 is 3. So essentially we're factoring out negative 3. So we could divide both of these two terms by negative 3 to find what goes here, which is 4x minus 3. Because negative 3 times 4x is negative 12x, and negative 3 times negative 3 is positive 9. Now, for something to be factorable by grouping, these binomials must match, which they do. So our final answer is 4x minus 3. We pull that out of both of these, and these last two factors drop down into a new set of parentheses. So this is the completely factored answer, and we did the problem by grouping. You could always check this. So 4x times x is 4x squared. 4x times negative 3 is negative 12x. Negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. The order is just switched on these, but that doesn't mean anything. These answers are equivalent. Number 33 has 3 parts. The first part is to find two numbers whose product is the 8 times 5, or 40, that adds up to 14. So you've got to think of what are all the multiples of 40. So we have to start with the multiples of 40. What multiplies to be 40? 1 times 40, 2 times 20, 4 times 10, 5 times 8. But we have the pair already. 4 plus 10 would be 14, and 4 times 10 is 40. So letter A is just asking us what those two numbers are that would multiply to be 40 and add up to 14. And those two numbers are 4 and 10. Part B is asking us to write 14x as two terms using the values 4 and 10. We would just change the 4 and 10 to 4x plus 10x. For part C, they're asking us to factor the problem by grouping. So that is why they had us go through this process, is because we want to rewrite the original problem, changing 14x into 4x plus 10x. Then we will factor out the GCF of the first two terms, which is 4x, leaving us with 2x plus 1, and the GCF of the last two terms, which would give us 2x plus 1. So the final answer, after pulling out the 2x plus 1, is 2x plus 1 times 4x plus 5. So you might have been able to find out those factors using a different method, but for this problem, they're wanting us to go through all 3 steps. Here's another factoring problem. You might recognize this as the difference of two perfect squares. A squared minus b squared always factors into a plus b, a minus b. If we take the square root of 169x squared and the square root of 9, which is 13x and 3, then those will be our a and b's that we plug into this formula. So our final factored answer would be 13x plus 3 times 13x minus 3. Feel free to multiply that out to check it, but that should work. The next question is another factoring problem. It is of the form of a difference of two perfect squares. So if we take the square root of both of these terms, we would get 9r squared and 16. Those are the a and b that we want to plug into the difference of two perfect squares formula. So again, a squared minus b squared factors into a plus b, a minus b. We should notice that we have another difference of two perfect squares here. So this one will go further into 3r plus 4 and 3r minus 4. So the final answer is going to be 9r squared plus 16 times 3r plus 4 times 3r minus 4. Keep in mind there is no sum of two perfect squares formula, so the 9r squared plus 16 cannot be factored further. So this is a final answer. This next problem has already been factored, and they just want us to solve for x. Recall that we can use the property that if a times b equals 0, then either a equals 0 or b equals 0. Although this is an or statement, this typically leads to more than one answer. So in our problem, 4x times x minus 3 equals 0. So either 4x equals 0 or x minus 3 equals 0. Dividing both sides by 4, we get our first solution of 0. Adding 3 to both sides, we will get our next solution of x equals 3. We could check these by substituting them into the original problem. If you substitute 0 right here, you would get 0 times x minus 3. And 0 times anything is 0, so that one checks. Then we could substitute 3 into this expression here, so 4x times 3 minus 3 is 0, so 4x times 0 is also 0. So both of these check. These are our two answers. This problem has already been factored as well, so we can set both of the factors equal to 0 to get our two solutions. 7x minus 2 equals 0, or 3x plus 10 equals 0. Adding 2 to both sides, we get 7x equals 2, and dividing by 7, we get x equals 2/7 as one of our answers. For the next problem, if you subtract 10 from both sides, we get 3x equals negative 10, and dividing by 3, we get x equals negative 10/3. So those are our two solutions. This problem has already been factored on the left side. However, since the right side does not equal 0, then that factorization is not going to be useful. So we need to multiply this through. X times 2x is 2x squared, and x times negative 7 is minus 7x. Then we will subtract 39 from both sides. Subtracting 39 to both sides allows us to move that term over and set it equal to 0. At this point, we want to factor it, but the original problem is asking us to solve. So once we get it factored, we will set our factors equal to 0 to solve the problem. We know that 2x times x is 2x squared, and for negative 39, we have a few choices. I think 1 and 39 are going to be too far apart to add up to negative 7, even when the 1's being multiplied by the 2. I'm going to focus on 3 and negative 13, or negative 3 and positive 13. And because I want them to add up to the negative 7, I'm thinking I want the negative 13 here and the positive 3 here. Let's go ahead and check it and see if that works. 2x times x is 2x squared, and negative 13 times 3 is negative 39. So we just need to make sure the inner negative 13x and the outer positive 6x adds up to negative 7x, and it does. So because that checks, that's our correct factorization. And we're going to solve it by setting our factors equal to 0. The second one, if you subtract 3 from both sides, we get negative 3. The first one, if we add 13 to both sides, we get 2x equals 13. So dividing by 2, we will get 13 halves as one of our answers, and negative 3 is the other answer. I encourage you to try all these problems again and see if you can verify them on your own. Thanks for watching this video. Please subscribe for more math tips.